Okay, if you have your textbook, okay, turn to page 34. Okay, wait, I have to share first. Okay, can see your screen? Okay. Okay, so this one actually that day we start a little bit, and then the beginning of the chapter we start a little bit for this. Okay. So maybe I go through again with you. Okay. So you know that the gradient of the curve is also the gradient of the tangent. Then I explain to you what is the meaning of the tangent. Okay, tangent it cut the curve at only one point. Like this, it didn't touch the curve. This one is not tangent. Like this line, okay, the straight line touch the curve at 2 points. This one also is not tangent. Only this type, it cut the curve at one line, okay, at one line, 1 point. So this one we call it tangent. Okay, this line we call it tangent to the curve at the point B. Okay, so when we say gradient of the curve, it also means that the gradient of the tangent. Okay, and then this one we also revise if we want to find the gradient of the tangent AT, this line AT, okay, or a straight line, we're using this formula y2 minus y1 over x2 minus x1. Okay, this one is provided we have the point, we have the coordinate of the point A and the point T. Point A, no problem, is because this point is fall at the curve y equal to x squared in this case for this graph. Okay, but the point T will have a little bit of problem. Okay, sometimes we may not know the point T. Okay, so this is a revision also. Okay, if you have a straight line, okay, how to find the gradient. Okay. Okay, so you see this part. Okay, using a graph to obtain the gradient can be difficult and also inaccurate. Okay, this is because the point T here in this case. Okay, sometimes we don't know the coordinate for the point T. Okay, there are other methods to find the gradient of the curve at a particular point. That is by using the idea of a limit as in the discovery activity below. Okay, we have learned the idea of limit. So we're going to apply the idea of a limit, okay, to find the gradient of the curve. Okay, actually beginning of the chapters that we have learned this dy dx by using the formula lah. Okay, so actually you can get the dy dx very fast by using the formula. Okay, that one is afterwards you can use the formula method to know whether your final answer is correct or not. But when the question mentioned you need to use first principle method, then you got to exactly follow the first principle method. Okay, this is what we're going to teach today, the first principle method. Okay. Okay, so today our index will be this whole thing. Okay, this first derivative of functions, okay, by using first principle, or you can just write first principle also can. Okay, this is the index for today. Okay, today is what? 8. Okay, happy woman days. 8. Okay, then using the same book MS2. Okay, let us see this activity. Okay, I open to the link. Okay, this is the link. Some of you got no textbook, so I have to return to the textbook. Go through this first to explore the gradient of the tangent functions and the gradient of the tangent to the curve. Okay, y equal to x squared at the point B 3, 9 using the idea of limit. Okay, so we go to the link. Okay, consider the curve y equal to x squared and the line that passes through point 3, 9 and the point 4, 16 on the graph. Okay, we go back to the link. Y equals to x squared. This is the curve. Okay, then there are 2 points. Point B 3, 9. Point C is 4, 16. Okay, then here they show you the M, the gradient of the line BC. Okay, currently is 7. Okay, they use 16 minus 9 over 4, 4 minus 3, okay, they get 7, currently is 7. Okay, then they say that, okay, go back to the text. 4, drag point C nearer to point B and observe the change in the value of M. This one, you see, when they say that they drag the point C nearer to point B, this is something to do with the limit already. Limit, the idea is, is nearer and nearer to a point. Okay, so you drag the point C to nearer to point B, it apply, okay, the idea of limit here. Okay, so record the change in the value M as a point C move closer to point B. Okay, so let the coordinate of point B 39 be xy and the coordinate of C 416 be x plus delta x. Okay, this symbol we call it delta x. Okay, afterwards we will go through it. Okay, the meaning is a small change in x. Okay, and y plus delta y. Okay, sometimes I will just read del x del y lah. Okay, you can read delta x delta y. Okay, the meaning is small change in y. Okay, if you having the textbook, you go here. Okay, symbol delta x. Del x is read as a delta x, which represent a small change in x. Okay, then this is small change in y, delta y. Okay, come back. Okay, where delta x represent the change in the value of x and delta y represent the change in the value of y. Copy and complete the following table. Okay, so at first, okay, the del x means the difference in between the point C and the point B. The x coordinate, okay, the difference in the x coordinate, okay, therefore 4 minus 3, then you get 1. Okay, so x plus del x means this, the point C coordinate, okay, is 4. Okay, y plus del y, so the y coordinate for the point C is 16. Okay, then what happened to the del y? Okay, del y is, okay, the difference of the y coordinate, so 16 minus 9, so it's 7. Okay, next, del y over del x, this one for you to get the gradient, del y over del x. Okay, so this divide by this, 7 divided by 1, then you get 7. Okay, this is for the first, when the point C is still 416. This is how they get the first row. Okay, now, okay, you can look at the diagram here. Okay, so now they label the B as xy, they label the C as x plus del x, y plus del y. Means here will be del x, here will be del y. Okay, so x is here plus del x. Therefore, they give you the x coordinate for point C. Then y is here plus del y. Then they give you the coordinate for the point C, the y coordinate for the point C. Okay, so here is del x, here is del y. Okay, how to find the gradient? Okay, del y over del x. Okay, del y over del x. Okay, to find the gradient. Or same thing lah, del y actually is the y2 minus y1. Okay, del x actually is the x2 minus x1. Okay, then you get the gradient. Okay, now they want to change the point C nearer to the point B. Means maybe it come here already. Okay, it come here already. Okay, this is for del x is 0.5. Okay, at first, here to here, the difference is 1. Okay, next, when they move the point C nearer to here to here, okay, let's say this is 0.5. Okay, 0.5. Okay, then nearer 0.05, then nearer 0.005. Okay, closer and closer to B. Okay, then we will see what will happen to the dy dx, what will happen to the gradient. Okay, so this part, okay, you may fill out. Don't want to fill out, let us see, okay, how the software can help you in this part. So next, I'm going to drag, okay, the point C so that nearer to the point B. Okay, what I will see what will happen original the gradient is 7, then it will become what? Okay, so now we do. Okay, do what? Okay, this one drag. How to drag? Okay, I try. This one. Oh, can. Okay, now you see, I move the point C nearer to point B. Now you see the gradient from the 7, it drop. Okay, from the 7 you go to, oh, okay, now 6 point something, 6.6, 6.6. Okay, now nearer. Okay, 6.4 already. Now nearer. Okay, 6.3 already. Now nearer, closer, 6.2 already. Okay, I don't know whether I can some more. Okay, now it's very close already. I don't know whether I can overlap. I don't think I can overlap it lah. Okay, so you can see the gradient, it dropped from 7 until it's near to 6. Okay, until it's near to 6. If you want, you can fill out all this. Okay, then you can see here, this one is from 7, drop until very close to 6. Okay, approaches 6. This symbol, the arrow, remember that then you learn. Okay, approaches 6. dy dx approaches 6. Okay, maybe here is 6 point something lah, 6 point something. If I want, I have to drag exactly, until 0.05 and then see what is the answer here lah, but I don't want to waste the time to get the accurate answer here. But I want you to know the idea. The gradient actually is start from 7 and then it go near and nearer to 6. Okay, so when del x approaches to 0, means the is very close to point B already. The point C is now very close to point B. What happened to the value of a del y over del x? Okay, so the del y over del x is very close to 6. Okay, compare this result with the result of them in step 5. Okay, so this one by filling up the table lah. Then step 5 actually is by using the software lah. So this one I don't want to do. Okay, so by using the software, you can see the del y del x is very close to 6. Okay, remember this value very close to 6. After we will do, okay, and then prove this is 6 lah. Okay, from the discovery activity 2, note that point B and the point C are the 2 points close to each other on the curve. Okay, we go to the next page. Okay, this is the idea. Okay, this is the idea. Okay, so first of all, point B and the point C. Okay, this line. Oh, the line, maybe you can't see very well. I think it's this line. Okay, the first line. Okay, then they get the gradient. Okay, the gradient of the line BC. Okay, same lah. So you get the del y over del x. Okay, so now you know actually the del y del x is the gradient. Okay, same as the y2 minus y1 over x2 minus x1. Okay, so as point C approaches point B along the curve, the line BC change become BC1 and then become BC2. Okay, so now like just now, okay, you drag the point C to C1. Okay, so now the gradient is changed to this, the second line already. Okay, then you drag again the point C to the C2. Okay, the gradient change again. Okay, to the third line, third blue line. Okay, that is the value of a del x getting smaller and approaches 0. The concept of limits, okay, we apply here. Okay, del x approaches to 0. Okay, when the point C is at point B, just now you remember using the software. Okay, it's very close. Okay, it's almost like touching the point B. Okay, then what will happen? Okay, when the point C is at the point B, the line becomes a tangent at B exactly. Okay, now they assume the point C exactly touch at point B. So now the line, you can say that is the tangent at B, okay, because it only cut the curve at one point, which is the point B. Okay, so you can say the gradient of curve at point B is equal to the gradient of the tangent BT. Okay, BT, but the T is the point is out from the curve lah. Now this is the last. Okay, this is the last one. Okay, then is equal to the value of, okay, dy dx. Okay, put the limit Okay, when del x is approaches to 0. Okay, here we apply the concept of the limit. Okay, so for the curve y equal fx, the gradient function of the tangent at any point can be obtained by finding this. Okay, so this is the it explains why. Okay, we use this to find the gradient. Okay, so this method we call it by using first principle Okay, this one is called the first derivative of the function with respect to x and is written with the symbol of dy dx. Okay, therefore we can write in this way. Okay, dy dx is this. Okay, dy dx is this. Okay, and then this one del y. Okay, we can write in this way. Okay, after I will explain why the del y is this. Okay, you see. Okay, how to say? Y equals to fx. Y equals to fx. Okay, therefore this is what? This is y. Okay, then this is what? Okay, if y equals to fx, okay, then when you see f, x plus del x, actually this one is y plus del y. Okay, 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 I write again. Y is equal to fx, then y plus del y is equal to f. Okay, x plus del x. Okay, therefore this minus this, okay, you get back del y. Get back del y. Okay, difficult law, first principle. That's why some of the school they skip straight away. They don't do this first principle. Okay, the gradient functions of a tangent dy dx can be used to find the gradient of the tangent at any point. Okay, x, y. This one they don't write y. Okay, instead of y they write fx. Okay, because y is equal to fx. Okay, so for example, take the earlier function. This one x squared. Now we're going to do by using first principle. Okay. One more for you. Okay, dy dx does not mean dy divide by dx, but dy dx is the symbol for limit del y over del x when del x approaches to 0. This one I think you know lah. Dy dx not the meaning of dy divide by dx. Okay, so this part, okay, afterwards I will go explain to you. See? Okay, the gradient of the tangent to the curve y equal to xx at the point B 3, 9, okay, is this. Okay, after they get ready, okay, then they substitute the point B. Okay, then this one we call it differentiation using the first principle. Okay, this method. Okay, now we come back here. Okay, here I'm going to change a little bit of this. Okay, because I see some of the other reference book. Okay, by writing the del x, you see this, someone with a square, you got to put a bracket. This one is very confusing. Therefore, some of the reference book, instead of using del x, they are using h. I think h will be more easier. Okay, so this is very hard and very dry, so you have to memorize it. Okay, memorize the method. Okay, so now we start. Okay, so I using another page. Okay, let us start with this. Okay, y is equal to fx. Okay, is equal to x squared. This is the functions. Okay, so I'm going to do is, okay, I replace. Okay, when you see your textbook, the del x, I'm going to replace it with h. Okay, so the dy dx, okay, limits, okay, del x, the del x approaches to 0, correct or not? Okay, I don't want to write del x, okay, instead of the del x, I write h. Okay, so h approaches to 0. Just how I use this. Okay, h approaches to 0. Okay, same. Here is the f x plus del x. Okay, instead of del x, I put h. Okay, minus fx over, okay, over del x, same thing. Instead of del x, I put h. Okay. Okay, so this one you have to write in your notes. Okay, this is very important. Okay, then followed by this example lah. Okay, so first of all, I need to find this. I don't want to keep repeating while writing limit. So what I'm going to do, I find this one first. Okay, fx plus h minus fx. Okay, I'm going to do this. First step. So once you know this formula already, you agak know what you're going to do. Okay. Okay. So what is the fx? Fx is x squared. What is the x plus h? Okay. So you see this x now become x plus h. Okay, and then squared. Okay, minus fx is x squared. Okay, this is what you learn in your form 4 lah. Okay, so here you need to do expansion. Okay, so x squared h squared 2xh minus x squared. Okay, so this one no more. So 11. Okay, 2xh plus h squared. I factor out 1h. Okay, so it will become like this. Okay, next. Okay, I want this over h. Okay, over h. So over h. Okay, will be this. Okay, what you get from here, okay, over h. Okay, so you can cut. Okay, so now this thing becomes this. Okay, then if I put in limits, okay, means I'm going to do, okay, limit for this. Okay, so you still remember our previous lesson? Okay, you can do direct substitutions. Okay, if this one not give you the answer 0 over 0, then that is the answer. Okay, so next step, 2x, okay, plus h. H now is 0, so your answer is this. What is this? This is dy dx. dy dx 2x. Okay, so if by using formula, okay, if you have y equals to x squared, okay, by using formula, very fast, right? How to do dy dx? Answer 2x, finish. Okay, here for you to check answer 2x, correct. Okay, but by using first principle method, you got no choice. You have to go through all this. Okay, so now we come back to the textbook. Okay, the answer is 2x. Now here, the answer is 2x. Okay, we continue. Okay, remember the point B, okay, is 3, 9. Okay, therefore, the x here is 3. So you substitute here. Okay, so 2 times 3 is 6. Therefore, just now you remember, when I drag the point C nearer and nearer to point B, the gradient, it starts from 7 and then it drop until it's very near to 6. Okay, until it's very near to 6. Correct, lor? Okay, so in general, the process of determining the gradient function dy dx, or the first derivative of a functions y equal fx, is by using the idea of this, okay, limit of this, which is known as the differentiation using the first principle. Okay, the methods we call it first principle. Now we do more questions. Okay, we do more questions. So I'm going to show you this 3 example. Okay, the first example, okay, all using first principle, okay. After a few example, I hope you are okay with this method already lah. Okay, y equals to 3x. Okay, we come back here. Okay, so this is a function, y is equal to 3x, okay, or we can write fx is equal to 3x lah, okay. Then, if we using formula dy dx, what's the answer? Hey, Aksa, I don't know whether you can reply me, Aksa. Okay, A1 is here already, 22. Aksa. Sophia here, Sophia. Sophia. Oh, all not here already. Janelle, are you here?
Yes, teacher.
Oh, okay, luckily. Sophia here. Aksa here. Okay, Sonia Sri here. Mampu loh like that. I call satu orang tak ada, dua orang tak ada, tiga orang eh. Sonia Sri. Okay, how about Siti Farah?
Yes, teacher.
Oh, okay, luckily. Siti Farah, come, help me with this. Okay, if I have a y equal to 3x, what is the dy dx by using formula?
3 by using formula.
What's the answer? Dy dx is?
3.
3. Okay, thank you very much. 3. Okay. Siti Farah. Okay, I don't know whether I have give you mark. If I didn't give you mark, then I can give you 1 mark here. Siti Farah. Given already, well. So I should call the one I didn't give yet now. Okay, I come back here. Okay, now by using first principle, okay, I write out the how to say the formula. This one same thing will not given. H x plus h minus fx over h. Okay. So first I want to find this. Okay. So if fx is 3x, then fx plus h, replace this x with x plus h. Okay, so expand. Okay, so 3x minus 3x, so balance 3h. Okay, next. Okay, so fx plus h minus fx is this 3h over h. Okay, so when you substitute h equals 0, there's nothing for you to substitute. So the answer is 3. Okay, same as this, the answer is 3. That's all. Okay, if you say this is difficult, not really difficult. Okay, it's just, you need to write it. Okay, but maybe the next question will be difficult. I don't know. Okay, so this is look like quite simple. Next question is 3x squared. Okay. So I open the new one. Okay, next question is 3x squared. Same thing. I'm going to do by using formula first. Okay, next girl, how about Wei Zian? I want to give you 1 mark. Come on, help me. Wei Zian here? Wei Zian. Wei Zian. Wei Zian nào Wei Zian? Oh, okay. She typed. Okay, Wei Zian, can you please help me with, by using formula, okay, find the dy dx for this. This one. Okay, y equals to 3x squared. By using formula, what is the dy dx? You can type. Okay, 6x, thank you. Okay, so this is 6x, huh? Okay, so I'm going to give Wei Zian 1 mark. New here. Okay, now fx is 3x squared. Okay, same thing. I'm going to write out the first principal formula. Limit h approaches 0, f x plus h minus fx over h. Okay, I do the same thing. I'm going to get this one first. Okay, so if fx is 3x squared, okay, so what is fx plus h? Means when you see x here, you replace with x plus h. Okay, so it's 3, then x plus h, and then square. Okay, so you need to do the expansion. So x squared here, h squared here. Okay, 2xh, okay, minus 3x squared. Okay, bring in the 3. So 3x squared, 6sh, 3h squared minus 3x squared. This and this, okay, no more. Okay, so we have 6sh plus 3h squared. Okay, I know that after I'm going to cut with h, so I purposely factor out h. Okay, continue. Okay, so now the numerator, okay, I copy from here. So h 6x 3h divided by h, cut. Okay, substitute, direct substitution, h equal to 0. So this one equal to 0. 3 times 0 is 0. Okay, so balance 6x. See, 6x. Okay, your answer is correct. Okay, the second example looks still okay. Okay, now we go to the third example. Okay, we go to the third example. Okay, third example, we are having y equals to 3x to power 3. Y is equal to 3x to power 3. If Aksa is here, anytime you want to cut anyone's queue to answer the question, I don't mind. I just want to try to encourage you, because seldom I can hear your voice. Okay, so next girl will be Ravania. Ravania, I hope you are here. Always, I remember, always you will answer me, Ravania. Hello, Lavania. Ravania. Okay, maybe you want to give the chance to the next girl, Ruzaina. 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 Farah, teacher, is the limit always 0? Not necessary, but for first principle, yes. Okay, the limit for the h is always approaches to 0. Okay, Rosanna, thank you. Can you help me with this, Rosanna? Okay, you got no mic, then you just type. Okay, so can you help me with this? By using formula, find for me the dy dx for y equals to 3x to power 3. What's the answer? Okay, answer come ready. Okay, 3 times 3 is 9. Okay, then the power is minus 1. So it's 9x squared. Okay, thank you very much, Rosanna. Okay, so this is 9x equal 2. Okay, so afterwards, when I use first principle, I also hope that I get this answer. Okay, 9x squared. If you don't get 9x squared, something wrong already, lor. Okay, I'm going to give Rosanna 1 mark here. Okay, I don't know what happened to Ravania. Same thing, Ravania. Afterwards, if you are here, please, you can cut anyone queue, okay, to answer the questions. Okay, now, first principle. Okay, so fx is 3x cubed. Okay, so I want to get, okay, the formula, dy dx, limits h approaches to 0, f x plus h minus fx divided by h. Okay, so first, same thing, I get the denominator. Okay, so fx is 3x cubed. Okay, so fx plus h, okay, will be 3. Okay, when you see x, you got to write x plus h power 3. Okay, so now you will have the problem in this expansion because of the power 3. Okay, and then I remember I show you before the binomial expansion. My binomial expansion. If you don't want the binomial expansion, is okay. Okay, so you just expand normally. Okay, so we start lah. Okay, so this one I'm going to do in this way.
Teacher, the binomial expansion, how?
You still remember? I think I showed you before, no meh?
You got show us before, but forget it. Binomial expansion is more easy, right?
I mean, but you have to how to say? Okay, I show you. Nah, you need to memorize, not to say memorize. Okay, you need to know this, the triangle. Okay, how to get this
But
triangle?
teacher,
Ah,
you expand square, that's how I also expand the cube. But I will get the answer.
that's why lah, can. Okay, if not, then you can shortcut way means I mean faster way you don't do the expansion then you just use this triangle. Okay, how to build this triangle? Actually, not that difficult. First, we will start with 1. The first row is one number only. Second row, 2 number. Third row, 3 number. Fourth row, 4 number. Okay, then fifth row is 5 number, and etc. Okay, first row we have only number 1. Okay, second row we have 1 and 1 still. Okay, you see all at the corner here is 1. All at the corner here is 1. Means the first and the last number for every row is 1. Okay, then we come to the third row. How to get this number 2? Okay, this 2 is by using the top 2 number. Hey, can you all see my cursor? The small hand? Dashna? Can see my hand or not?
Can,
Can,
teacher.
okay. So these two actually by using the 1 on the top here. 1 plus 1, you get 2. Okay, or not? Okay, then come to the fourth row. Okay, same thing. The first number and the last number always is 1. Okay, how to get the 3 here is by add out. Okay, the row on the top here, 1 and 2, you add out, you get 3. Okay, here also the same thing. 2 and 1, you add out, you get 3. Okay, so now, okay, the expansion is in this way. I think I showed you before is a video, if not mistaken. Okay, so 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. Okay, so I go back here. I don't know whether I can do it here or not. Okay, so you see, okay, I draw out the triangle. You have 1. Okay, second row 2 number, so it's still 1, 1. Okay, third row 3 number, 1, 1. Okay, then this 1 plus 1. Okay, 1 plus 1 will give you 2. Okay, then we come to the fourth row, is a 4 number, so 1 and 1. Okay, remember the first number and the last number is 1. Okay, then 1 plus 2, 1 plus 2 will give you 3 here. Then 2 plus 1, okay, will give you 3 here. Okay, so let me think. 1, 2, 1, 1, 2, 1 is which power? 1, 3, 1, 3, 1, 3. 3 is power 3. 3 is power 3. Okay, so this is power 3. This is power 3. This one is for a plus b power 3. This one is for a plus b power 2. Okay, these two got no meaning lah. If you want to say this is a plus b power 1, and then this one is a plus b power 0 lor. Okay, anything power 0 you get 1 ma, so it's 1 lor. Okay, power 1 means what? Power 1 means you don't have to write anything ma. So this one actually will give you a plus b lor. Okay, the 1 1 means what? The 1 1 means the number here, the number here, 1 1, the number here. Okay, so what is this? Okay, this square no problem for you to expand ma. Okay, shortcut way. Okay, so this 1 2 1 means what? 1 2 1 means here 1 2 1. So now you know the triangle, the meaning already. Okay, so 1 3 3 1, it means what? Okay, it will be like this. Okay, you see a to power 3, a to power 3 first, then it will drop. Okay, a and b. Okay, it will drop the power. The 3 here we will drop 1 power 2. Then b here, nothing means b to power 0. So here it will increase. b will increase the power. So this one is 1. Okay, 0 to 1. Okay, then a again will decrease the power. So 3, 2, here will be 1. Okay, then b will increase the power. Here 1, here will be 2. Okay, then last one will be b to power 3. Okay, a will be power 0. Okay, then the 1 3 3 1, then you fill out. Here is 1 3 3 1. Okay, so the expansion for the a plus b power 3, this is the answer. Okay, by using of this triangle, okay, to help you to get the answer. Okay, if I show you one more, a plus b power 4 okay, so again so this is 4 number already. Next one is 5 number. Okay, so how to get second number? 1 plus 3 is 4. How to get the third number? 3 plus 3, 6. Okay, then how to get the fourth number? 3 plus 1, 4. Okay, okay, so the expansion for the a plus b power 4 will be like this. You start with a to power 4, okay, b to power 0. Then a will drop, b will increase the power. Okay, so 3 1. Then a again drop, so become 2, b increase Okay, 2. Then right here, tak cukup tempat. Okay, A, B. A again drop, so become 1. B again increase, so 3. Okay, last. Okay, A drop again, so 0. B power 4. Okay, then 1, 4, 6, 4, 1. You fill out here. 1, 4, 6, 4, 1. Then you don't have to do the expansion. Okay, you just remember A to power 0, all this is 1. Okay, B to power 0 is 1. So no need to write. Okay, then here the power 1, no need to write. Okay, here the power 1, no need to write. Okay, so this is the expansion. Okay, this is one way of doing that. Okay, when your power is very big, example power 10, you still can using this triangle to help you, you don't have to do the expansion. You do the expansion, easy to make mistake actually. Okay, but here power 3 I think still okay lah. So we just do expansion, then after that we compare with this binomial expansion. Okay, so we come back here. Okay, this one will do nothing yet. I'm going to expand the square first. Okay, the shortcut way. Okay, after that, okay, the 3 I leave it first. Okay, now this and this, these two bracket, okay, I'm going to do one by one. So first term, okay, to every term in the second bracket. So x to the power 3, 2x squared h, and then xh squared. Okay, now second terms in the first bracket to every term in the second bracket. So x squared h, 2x h squared, and then h to the power 3. Okay, I have done the expansions. Okay, next, before I bring in the 3, okay, I should group the like term, okay, then arrange it nicely. Okay, same thing actually, x to the power 3 first. Then after that, the next term will be find the one with x to the power 2. X to the power 2 here, x to the power 2 here. Okay, so 2 and 1. Okay, so okay, 3. Next, find the one with x to the power 1, x to the power 1, x to the power 1. Same thing, 2 and 3, 2 and 1, so it's 3. X, okay, h squared. Okay, last term, h to the power 3 minus 3, x to the power 3. Okay, now you can compare this with just now the expansion. Correct or not? Okay, you see, here is 1, 3, 3, 1. Okay, then the power from the x decrease, then power for the h increase. Okay, so you can either use this method, if not then use just now the binomial expansion method. Okay, next I'm going to bring in the 3, okay, to every terms. Okay, so 3, 9, 9, 3. Okay, you see, always this one you can cut away. Okay, so next you remember I always want to factor out one h. Okay, so I continue with the dy dx. Okay, the numerator I'm ready with this. Okay, and then OH. So this H you can cut. Then, okay, direct substitution, H equal to 0. This one no H. This one got H, so this term will become 0. Second term becomes 0. Third term also becomes 0. Okay, with the substitution, H equal to 0. Therefore, the balance is 9x squared. Correct or not? Check and see just now the answer. The direct using formula 9x squared. So, it's correct. Oh, we still left only 4 minutes. I don't know whether I can show you one more example or not. Quickly lah. Cepat. Okay, this one actually is inside your exercise 2.2, question number 2. So I'm going to show you, so you don't have to do these questions. Okay, so question number 2. Okay, this is the y. Okay, so same thing by using first principle. Okay, so fx is what? Okay, I got no time already. So I'm using a formula. This one I do at the side. After I'm going to check the answer. Okay, so this is for x, okay, minus 1. Okay, I hope I'm going to get 4x minus 1 at the end. Okay, so this one is the fx. Okay, so I'm going to get this. Okay, so fx got no problem, but here you will have problem with the minus. Remember, put bracket. Then after that, the sign got to change. Okay, so fx plus h, same thing. When you see x, you write x plus h. When you see x, you write x plus h. Oh, my goodness, so big the expansion. Okay, I don't know if it will work or not. It not work, mean you got to do term by terms. I'm not very sure. Okay, let us try. Okay, expand. This one expand. Okay, this one also expand. If I'm late a bit, monitor or the assistant, please inform your next class teacher. Give me 5 more minutes. Okay. So here bring in the 2. Panjangnya. I don't know whether it work or not. Okay, see this and this. Okay. This also 1 negative 1 positive. Okay, this also 1 negative 1 positive. Okay, now I think it worked. Okay, same thing. I can factor out h. So it's 4x 2h minus 1. Okay, next dy dx is equal to limit h approaches to 0. Okay, this is the denominator. 4x 2h minus 1 over h cut. Okay, direct substitute, h is 0, so the second term becomes 0, so left 4x minus 1. Bingo. Okay, you get an answer. Okay, we come back to the textbook. Okay, for today exercise, today exercise, okay, do this exercise. Okay, but this question no need do. I choose some of the questions, but I can minus a few questions on it. This don't do, and this don't do. Okay, this one actually you can do, by just now. This one you better do, no need lah. Okay, because here you have a similar questions. Okay, but just now the example you want copy can. Okay, the rest all you have to do. Okay, this is today homework. Okay, I'm going to dismiss the class already. Wait for a while. Okay, let me stop recording.